Hey, these are the notes for 1.4 section in our text, and it's on estimating square roots. Deals with pages 22 to 27. So when we're looking for square roots, we don't necessarily always deal in perfect squares. And we have this example, which whole number is the square root of 96 closer to? So we have to ask ourselves, well, what do we already know? When we look at this, we know that 1 squared is 1. Therefore, the square root of 1 is also 1. All right? We have 2 squared is 4. Therefore, the square root of 4 is 2. Right? 3 squared is 9. Therefore, the square root of 9 is 3. See the pattern here? 4 squared is 16. Therefore, the square root of 16 is 4. And we can do this on and on. 5 squared is 25. Square root of 25 is 5. 6 squared is 36. Square root of 36 is 6. And just right now, just continue this pattern until we get up to, let's get up to 10. All right? I'm going to pause this, and you can do this on your own. So now you see what we have here. We have squaring numbers all the way to 10 squared. We have the perfect squares for them. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are all perfect squares. Let me just change this color and let you know that. These are perfect squares. And then here we have the square roots. All right? And now when we look at which whole number is the square root of 96 closer to, well, we can go, let's go here. We have 96, well, we have the square roots of 81 and 100. Okay, 96, the square root of 96 is going to be somewhere in between here. Therefore, which whole number is the square root of 96 closer to? Well, would you say 96 is closer to 81, or is it closer to 100? In this case, the square root of 96 is closer to 100. Therefore, the square root of 96 is going to be closer to 10. All right? That's where the square root is going to be closer to. And that's just basing it on what we know. Another way to do this is if we take a look at example 2. Between which two consecutive whole numbers is the square root of 5? All right? Well, so let's write this down. Let's go with the square root of 5. Well, let's look back up here. What are some perfect squares that we have here? We have the square root of 4 is on one side of it. I'll just change colors here. Square root of 4 is on one side of 5, and the square root of 9 is on the other. So what two consecutive whole numbers is the square root of 5 between? Well, what's the whole number? Square root of 4 is 2, and the square root of 9 is 3. So, the square root of 5 is between 2 and 3. Example we can look at is placing it on a number line. So we can place the square root of 30 on the number line to show its approximate value. So we go, okay, well, what are perfect squares that are close to the square root of 30? We know that, changing pen colors here, we know that the square root of 25 is 5, okay? And the square root of 36 is 6. 30 is about halfway between the square root of 25 and the square root of 36. So we can actually safely plunk the square root of 30 about halfway between 25 and 36. Therefore, it's probably around 5.5. And if we check that out with a calculator, okay, 5.5 squared equals, let me just bring up a calculator here, 5.5, oops, it's not working here, 5.5, and I'm going to square it, is 30.25. Close enough. All right? Okay. Well, we'll write that down there, 30.25. That's pretty close to 30. Well, let's think about what we have here. Here's how we can apply this to problem solving. Okay, so a square garden has an area of 139 centimeters squared. Part A, what are the approximate dimensions of the garden to 2 decimal places? So if it's a square garden, right? Okay, it's the area, okay, that's all the space inside, is 139 centimeters squared. So to find out side dimensions, I'm going to put this down here, this is A. Side dimensions, we have to find out what's the square root of 139. Okay. Well, here's what I know. I know that the square root of 120, I'm not going to do that. So one way I'm just going to do this is I'm going to use a calculator to figure out the square root. Now this calculator that I bring up, usually a calculator is going to have a square root button on here. This one doesn't, the computer one. But I can type in 139, and I'm just going to click this little inverse key here. And I'm going to do the inverse of squaring a number, which is the square root. And it's going to show 11.789. I'm going to round up to the second decimal place. I'm going to say 11.79. Right? So equals 11.79 centimeters is the length of one side of the garden. And it's a square, so all 4 sides are 11.79. Okay? 11.79 centimeters is the length of one side. So, part B. Net wire fencing is needed to keep out coyotes. So about how much fencing would be needed around the garden? Well, we can take that 11.79 and we can multiply that by how many sides the fencing needs to go around. That's 4. So that's going to equal 47.16. 47.16 centimeters of fencing It's actually a small garden if we're dealing in centimeters. Probably better to have meters, but oh well, it's a math problem. Those are the ways to calculate square roots, side lengths, deal with perimeter, right? Your assignment, you have 3 options. Earth's orbit, right? Take it a little bit easy. Do numbers 5, 8, 11, and 15 on pages 25 and 26. Impulse speed, numbers 7, 8, 12, and 16 on pages 25 and 27 if you want a little more challenge. And if you want to be challenged a bit more, numbers 12, 15, 16, 19, and 23 on pages 25 to 27. Have fun.